Hi everybody, this is a short video on an answer key going over the classwork from last Friday, April 30th, about chi-square goodness fit test. So in the first problem, it's looking at a distribution of births according to the day of the week. And you can see here that these were the counts, and the sample was 150. And the hypothesis is are the births equally likely across the days? So the null is that all the days have the same proportion of births, and then our alternative is that at least one of the days has a different proportion. To get the expected counts in this one, when I'm saying equally likely, that basically means I can take this 150 and split it into 7 groups, divide by 7 or multiply by 1/7, right? And I get 21.4 as the expected count for every one of the days. To calculate chi-square, I basically subtract. I take the 11, subtract the expected 21.4, square it, and then divide by the 21.4. Do that for 27. Subtract, square, divide by the expected. One thing that you can do to help yourself out is if you want to do something in Google Sheets. If you open a Google Sheets and you enter the account, enter the one column as the observed, and then you enter the expected here. So I'm going to type in 21.4. In Google Sheets, something you can do is you can fill down. So if you put your cursor in the corner, you get this little gray cross. You can grab that and pull it down. It'll fill down. Now, in this third column, we're going to type in a formula. To type in the formula, I'm basically going to be clicking, I'll first type an equal sign, and now I'm going to enter the formula. So I want a parentheses, because in the formula, I first have to do the observed minus the expected. Instead of typing the numbers, I'm going to click on the cell I want. I want the observed, which is right there in this B3, so that's column B, row 3. And then I want to subtract the expected, which is there in C3. I'll type in the parentheses. I'll put in the squared, so that's shift 6 to get that caret squared. And then dividing, I use a backslash, and then I want to divide by the expected count. When I click enter here, so now this formula is the formula, and I can fill this all the way down. And this calculates all of the different elements all at once in this Google Sheets. And then down here, I can insert a formula. I go to insert, go down to function, and I basically look. Sum is the one I want, and then I can highlight all of the cells that I want it to sum up. When I do that, it gives me my chi-square, which is 13.63. Right, so, and sometimes I want to type chi-square, I could do capital X to the second, and this is 13.63. So on to the next one, degrees of freedom. There was 7 days, so I subtract 1, so my degrees of freedom is 6. To find the p-value, I go to my chart, and then I look degrees of freedom 6 is right there, and I go over until I find 13. So 13 is happening here in between 0.05 and 0.025, so I know that it's less than 0.5, which is really what I'm concerned with. P-value is between 0.05 and 0.025. And since the p-value is less than 5% significance level, we would reject the null hypothesis. There is evidence that the births are not equally likely across all the days. For number 2, we're going to do the whole test. This is about a traffic light. It has this claimed distribution. 80% is red, yellow percent 5%, and green 15%. A resident who must pass through is suspicious that the light is not functioning like it's claimed, and they set up a camera, so they get 200 randomly selected times, and they have the results 173, 13, 14. So HO, the proportion of time for the lights, is as claimed. HA, at least one is different. Alpha is 0.05. To get the expected counts, I'll go ahead and do it here in the plan. The main condition is that all expected counts are greater than 5. So I do 200 times the 80%, 200 times the 5%, 200 times the 15, and I get 160, 10, and 30. So I do have all expected counts greater than 5. A random sample was stated. Now let's go ahead and do the test. This is a chi-squared goodness of fit test. It's chi-squared goodness of fit because there's a claimed distribution with those percentages. Degrees of freedom here, there was three different light colors. I subtract 1, my degrees of freedom is 2. So now I do that same thing, and I can use Google Sheets once again. My observed was 173, 13, 14. Expected was 160, 10, and 30. And then I actually even just copied. I hit copy and I paste it over here. And if I look to see, is my function working properly? Sure looks like it, because it's doing the same thing. It's taking 173 minus the 160, squaring it, dividing by 160. When I fill down and I sum, I end up with a chi-squared that is 10.48 or 49. And then if I go to my table, I'm going to degrees of freedom 2, and it's pretty close to this 0.005. It's maybe a little more than that, but that's close enough. So I'm going to say approximately 0.005. My conclusion, since the p-value 0.005 is less than alpha, we reject the null hypothesis. There is evidence that the light is not functioning according to the claimed distribution. So that's it for this chi-squared assignment. Please let me know if you have questions. You can put them in the comments or ask them in class on Wednesday. Have a great day, and I will see you all soon.